We can write kinetic energy of system like this. Okay, I mean to say kinetic energy of the system with respect to center of mass plus kinetic energy of center of mass. We'll discuss about this in detail in say center of mass frame of reference systems. This term we can write as half into reduced mass into V relative का square plus half into total mass of the system into VCM square, where mu is called reduced mass defined as m1 m2 divided by m1 plus m2. So if we substitute this part, so we can write kinetic energy of the system. In the system, block and wedge are there, so I will write kinetic energy of wedge, kinetic energy of wedge plus kinetic energy of block, that is equals to half into reduced mass, that is capital M into small m divided by capital M plus small m into V relative का square plus half into total mass into VCM का square. Now we are applying work energy theorem here. So we'll write work done by gravity, that is equals to change in kinetic energy of systems, delta K, delta K. That means what? Work done by gravity is how much? Mg into R. Delta K E of system. See, the center of mass velocity is not going to change here. So that means this term will go to 0. So only this term is left. So this we can write half into reduced mass, that is equals to small m into capital M divided by capital M into small m into relative velocity का change in relative velocity का square. Okay, so finally it becomes capital V plus small v का square. Initially it was 0. So this expression we can write. We are interested into small v, velocity of the block. So we have to use again momentum conservation. From there we can substitute this part. So this we can write 2 mgr divided by reduced mass. That is equals to, if I substitute this part, this becomes capital M by small m, small m by capital M. Let me write that expression again. It was mv equals to this things. So we can write capital V equals to small mv by capital M. Substituting this part here, it is V square into, I think, 1 plus small m by capital M ka whole square. Rearranging this term again. So this becomes capital M plus small m by capital M ka whole square. I think one term get cancelled from both sides. Yeah, one term get cancelled on both sides. So again we are getting the same expression. Velocity of the block is under root of 2zr divided by capital M plus small m by capital M. This we can also write 2zr divided by 1 plus small m by capital M. So earlier also we got the same result. Again we are getting the same result. But this time we have approached by slightly different method. That is center of frame, we solve these questions. Okay. This expression of kinetic energy is important. Many questions, no doubt, in these questions we applied the almost same effort. But in many questions, if we use this approach, if we remember this result, kinetic energy, then two block system sometimes becomes very easy to solve. Thank you.